Good afternoon, ladies and gentlemen, and welcome back to the live demonstration area. This is the place to see groundbreaking technology every 30 minutes, every day at the JEC World Show. We are very pleased to welcome back to the demonstration area Magnum Venus Products. MVP is a global manufacturer of fluid movement and production solutions for industrial applications in composite and adhesive markets. Charles Turr is a renowned expert in resin transfer molding and infusion technology. This demo session will showcase the seamless integration of precision injection techniques with SVP seal technology. The collapsible silicone resin channel enhances the quality and efficiency of part injection, ensuring optimal resin distribution throughout the mold. Charles is going to show us this. Charles, the demonstration floor is yours.
Thank you very much, and welcome everyone. So I will continue the demo that I started yesterday afternoon, where I was showing what we call the SVB seal, which is a solution to seal a plastic bag without tacky tape, and we are going to inject the part. So just to show you what is it, SVB seal is a solution which is safe to replace the use of tacky tape. Of course, not for everything, not for very large part, but for most of the medium-sized part. So when we close the part, we have a plastic bag when we normally load and close with the tacky tape. Here you can see on that pictures, we have a swimming pool, the way that we produce swimming pool 15 years ago, and the way that we produce swimming pool today on the right pictures. As you can see on the left pictures, we still suck the resin from the drum. On the right pictures, we use an injection machine. We use also reusable resin channel and the SVB seal to seal the membrane. So the only waste we have is the plastic bag. So this is how it's working. We have two parts. One part that can be inflated or not, and the second part that will cover to seal the seal. Two-part seal, working like that. So we have the female mold. On the female mold, we load the glass. Then we put a resin stopper because we don't want that the resin go on the pipe. We want to work clean. Then we have, if necessary, a vacuum channel. And then we load the plastic bag. Now, with the second part of the SVB seal, we are going to push down the plastic into the groove. And the good point is, at this time, we do not care about folders. Folders are not our problem anymore. We just push the plastic down, taking care that we have enough material to go inside the mold, of course. Then we are able to pull the first vacuum. But we still leak. Where do we leak? We leak on the edge of the plastic. Why? Because even if we compress a little bit the plastic, the air can pass through. So in this case, what we do, we trim out the excess of plastic along the SVB seal. And then we come with the second part of SVB seal, which is a lips, that we clips into the first part. And at this time, we suck it down by vacuum. So we have along the mold, near the groove, a pipe that we laminate, where we pull the vacuum, and we have some hole that cross the mold outside. So it's worked like that, and if we want, we even have the possibility to inflate the seal to avoid that on the big part, the seal can escape. That is not necessary, and we don't do it here. So on the pictures, this is how it works. We load the bag on the top of the glass, on the top of the resin channel. We put the plastic bag in the groove with the first part of the SVB seal. Then we trim out the excess of plastic. And then we have the hole communication for the vacuum. We load the second part of the seal. We apply the vacuum, and then we inject the part. So before we are going too far on the presentation, I'm going to inject the part like that. You will see how it's working. So what I want to introduce is that we have here a valve, IVX3, that we use to inject, connected to the machine. And nearby, we have a sensor. The sensor will regulate the flow pressure. If the flow pressure is too high, it will automatically stop to send the air to the valve, and the valve will close. Then the resin will flow, the pressure will disappear, and then it will open again. The second thing that we have is a vacuum valve. When we start to inject the machine, we send the air signal to the valve, and at the same time to the vacuum valve. Then the vacuum valve will pull the vacuum and will open and collapse the resin channel that we have inside. The resin channel is working like that. We have one collapsible resin channel. And when I pull the vacuum in, here, what happened? It collapsed. So the resin can go. And as soon as we finish to inject, we stop, and it comes back flat. So you will not have any excess of resin. You even cannot tell how we inject the part. So we are okay, everything is connected. So I can go to inject the part. I have here the possibility to regulate the pressure. So I have here the injection machine. On that injection machine, I can preset the quantity of the resin I want to inject. Then what we have a security here. If for any reason the resin cannot go through the valve because something blocked, we'll have a back pressure. And by the power of the pump, we can destroy the pipe and to have resin everywhere. So this is why we have a security that we call MPG that will stop automatically the pressure when we have a back pressure. And we can set up the back pressure as we like, according to the length of the pipe and the pressure we inject. We have a catalyst alarm, a gel alarm, sorry, and all the system to recirculate, to inject and stuff. So let's inject. We have a camera on the top, so I think you will be able to see the injection. I start the machine, up, and I inject the resin. So the resin is coming. So what happened? The valve is closed. So now what I have to do, I have to open the valve. I open the valve, I send the air signal, and the resin flows. So you will not see the resin for the moment because it's flowing into the resin channel. The resin channel is big, it's 40 millimeter diameter, so we have to fill it completely before the resin goes out. So I can increase a little bit the speed to push the resin into the resin channel. And then you can see that the resin appears. So there is no need to inject too fast, except if we want to produce a lot of part. But anyway, we cannot inject faster than the resin can flow. So what I use here, I use a carbon fiber with a net on the top, which is a combi net, which is a material which is perforated plastic with a net on the top. So the resin flow, step by step, along the resin channel. So we have a full distribution of the resin along the resin channel. So we check, we don't have too much pressure. At this time, everything okay. So we just have to wait. You can see on the camera the resin flow. So what I have done also, to equilibrate the pressure, I stop the net 25 millimeters before the end of the part, where we have pure carbon. So you will see a full line regulate around going up. So as you see, we don't inject too fast, so we don't have too much pressure, so the sensor don't have to work. Normally, it works only at the very end. So everything is automatic, and as you can see, there is no air bubble. No air bubble coming from the border. Why? Because we secure with the SVB seal the leak. So the resin arrives on the front, pass through, so now it will arrive at the end on that point and on that point where we pull the vacuum. We still inject slow, so we don't have too much pressure, so the sensor don't have reason to work. We can make it more sensitive or less sensitive. The most important is that we are under control of the infusion. We control everything. So it's still going. As you see, so here it's touching the border now, on the back also. What we cannot forget is that the resin channel is full of resin. So we'll not stop. See here, we are on the limit, pressure is too high, and the valve will close. Up, the valve closes. Pressure is too much. So we stop to send air signal. So now we have to wait that the resin flow, it will stop, and it will restart. Everything according to the pressure. We have to wait, it will come. So we can manage it by hand to make it restart or not, according to what we need, but we are nearly on the hand. And I think that the resin we have on the resin channel will be good enough to fill the part. Yeah, you see, we can manage to make it work or not. There is no point to make it too much work. Voila. So for security, I will stop here. So then I stop. And now what I do, I close. I stop the machine. Forget. I close. And the only thing I have to do now is to flush. And the excess of resin that I have in the center now will fill the part and will finish to fill the part. That's it. So now, when I have stopped that here, I can disconnect that. There is no vacuum going out. Why? Because the valve stopped the vacuum. But not only, it let the air passing through. Because if you just stop the vacuum, that's not good enough for the collapsible channel to come back because it's still under vacuum. So you have to let air coming inside that to stop it. But you don't want to lose the vacuum that you have on the part if you use the same machine. So the valve makes the job. It stopped the vacuum and it let the air passing through for the collapsible channel to come back on its original position. So now we can leave it like that. It's okay. And we are going to continue the presentation and to show you what we can do. So that's the part we demold. After it, no gel coat, no air bubble. And then we have the collapsible resin channel working with the plastic bag. So we can have a solution where we have a full silicone membrane and a solution when we have a combination of silicone reusable channel and plastic bag as we do here. Both solution is working. So I will pass that, we don't need it. You see already what is it. We have an injection part, which is in the middle of the resin channel, which is here. And that injection port is very helpful. So what we do, we have it here. We pour the silicone, we demold, the 3D mold, and we get that part. That part has a lips. When you pull the vacuum on the resin channel, it opens the lips. So it can be straight, but also it can be cross. Okay? So it means we can do sequential infusion using only one injection port. We have done that with Colin here from City Platon. We have injected a part of 36 square meters, sending the resin on one side, then on the other side, then on both sides. So this is a 15-meter panel. The good advantage with the resin channel is that it's 40 millimeters. Instead to use the spiral tube, which are 10 millimeters, where every 4 meters you have to put a resin port, here you can inject the resin on one part and to send the resin for 15 meters. As you can see on that presentation, we send the resin on one side and we pull the vacuum on the other side. And look at that. One injection port, one vacuum port, 15-meter panel. Very simple, very basic. So this is what we do here on the swimming pool production. You see that? We inject the resin, and the resin moves down and infuse the part step by step. The only thing we lose is the plastic bag. So we have a 3D printed mold where we can make all the injection ports. And here we have a project for the wind blade. On the wind blade, we have the spar in the middle. And where is the spar? It has to be monolithic. So because it's monolithic and there is nothing to help the resin flow, we have 3 resin channels. 3 10 millimeter spiral tube. So for 15 meter, it was 15 resin ports. And the customer said, Charles, I want only 1 resin port for the full blade because it's too complicated. So this is why we decided to make a resin channel, which is with 3 lines and the cross injection port. So like that, we are able to make it. So we load the glass. There is no gel coat, the foam. Then in 2 minutes, we load the full 15-meter band. We close, plastic bag under vacuum, and we just inject the part from the center line first, and then line both sides. 1 injection port, 15 meters, and nobody around the mold. The machine do the job automatically. And then when you remove the silicone resin channel, as you can see, there is no excess of resin below. You even cannot tell how we inject the part. That's the good point about that. So again, thank you very much for your participation. I had more pictures, but I was not able to show. I'm sorry. We have a customer working in Netherlands where City Platon have done a fantastic job making 4 or 5 lines of 15 meters near to each other, 12 meters, sorry, and working beautifully. I was not able to put it on presentation. Sorry about that.
Okay, thank you so much, Charles. This is a great opportunity to ask Charles any questions that you have. Question over here, gentleman in the middle. In the middle.
Hello.
Charles.
Hi, Charles. Thank you for your demonstration.
Thank you for coming.
Sometimes we have a shorter length when the resin flow inside the pieces. And the resin goes to the vacuum channel.
Yeah.
What can we do for that? Sometimes if you have a shorter distance between resin distributor and...
I have it here. Here, I have my resin channel. The part is shorter here than here.
Yeah.
So what I do, I don't have any connection with the vacuum here because there is no need. I put the length of the resin channel to be sure that the resin will arrive first at the end, and then step by step will arrive to my vacuum. The only connection I have with the carbon fiber and the vacuum channel are these little 5 centimeter by 5 centimeter part to stop the resin. That's it. And look at the part, it's completely infused.
Okay, thank you.
That you decide on the strategy when you build the project. You don't arrive the hand on the pocket the morning to say, oh, I'm going to inject with a silicone. It doesn't work like that. You have to survey the project to see what you do and to survey the production. What we try to explain is everything we develop is focused on production.
Every 5 centimeter or every 25 centimeter is channel for vacuum?
No, not 25, 5.
5.
5 here, that one. 5 by 5, but it can be 20, it doesn't matter. The most important is to pull the vacuum where the resin arrives last.
Okay, thank you.
You're welcome. So as you can see, the part is completely filled and there is no air bubble inside the part. We inject this part in, I don't know, 5-6 minutes. The resin gel time, because we have to make several demos, is 30 minutes. So we have like 25 minutes for the air to come in. And there is nothing, just because it's impossible. Why? Because we pull the vacuum here. And we pull the vacuum where the air can come from. So we combine the vacuum. Where is it? Where the leak can be. So there is nothing and no problem in the middle.
Okay, thank you. Thank you very much, Charles. Any other questions?
Any more questions? You really understand everything I explained? Please.
You are pro, Charles.
Okay, if you have any question, you can come to me and we can talk. There is no problem. We are under schedule.
Yes, we have 10 minutes. You can discuss with Charles here.
Okay.
I'm sure he'll be happy to. Otherwise, don't hesitate to visit Charles and the MVP team at stand hall 5 U58. And Charles will be back again tomorrow for another presentation at 10:45.
Tomorrow, we are going to show something very specific. Yesterday, we show a silicon membrane. I use my time, I'm sorry.
Of course.
So we use a silicon membrane which is flexible. This is nice, but the point is, when you pull the vacuum, the first thing you do is to compress the glass. So then you increase the glass content, but you decrease the part thickness. If you use a lighter TM mold, you have a rigid counter mold, and then you control the part thickness because the counter mold touches the flange of the mold. But the point is, in lighter TM, you have to inject the resin all around. The advantage of the silicone is that you can inject the resin from the center. So you can manage your resin channel to inject the part very fast. Here I inject the part in 5 minutes, but I can inject this part in 2 minutes. So we have developed a solution where we make bond composite on silicone. So we are like in lighter TM, but with a silicone on the surface of the mold. So we are able to inject the part very, very fast and the part that don't need to be trimmed. So we are going to show that tomorrow on the next demo.
Okay, so if you're at the show, don't hesitate to come back and see Charles for this fascinating demonstration tomorrow at 10:45. Otherwise, he is here for your questions. And if you would like, you can also come back for our next live demonstration happening at 4:15, which will be with Rock Tool right here. Otherwise, ladies and gentlemen, we wish you a very nice afternoon at the JEC World Show. Thank you so much for coming.